Okay guys, so for the next video we're going to review an old formula called arc length. So for arc length here, if you have a circle, arc length is the measure of this piece right here. And there's not really a letter, so we're just going to call it AL. And we've talked about two different formulas. There is the degree version of the formula, which is arc length plays off circumference. So you do theta divided by 360 because that's the entire circle, and that's your central angle. I'll write it down in a second. Times 2 pi r is equal to your arc length. So as said earlier, theta is your central angle, and r is the radius of the circle. But the radian measure of the same thing is theta over something else times 2 pi r is equal to AL. But on the bottom here is 2 pi because that's the equivalent of 360 in radians. So for us to do the next set of problems, so for question 13, and I'm just going to put it here for a second, I'm assuming you're looking at it at the same time. The diameter of a circle is 8 meters. The central angle of the circle intercepts an arc of 12 meters. What is the radian measure of the circle? Now, before I actually draw this on paper, what you need to realize is it gives you the diameter, not the radius, and diameter is the full thing. And you're told that the diameter is 8 centimeters long. So if the diameter is equal to 8, to find the radius, you have to take the 8 and divide it by 2. So the radius of the circle is actually 4. So what is actually going on question 13? The radius of this circle is 4 centimeters long. And it says the central angle of the arc intercepted of is 12, I'm sorry, it's 4 meters. I read it wrong. But there's an arc that's intercepted, and this arc is 12 meters. And this is your arc length. What is the radian measure of the angle? So you have to know that the formula is theta divided by 2 pi times 2 pi r, and we're going to set this equal to AL. Theta is what we don't know, but we do know r is 4. So we'll have theta over 2 pi times 2 pi times 4 will be equal to 12. The nice thing about the radian version is, since there's 2 pi here and 2 pi here, we can cancel the pi's out, and we can bring the 4 and the theta together, and we get 4 theta is equal to 12. Divide both sides by 4, divide both sides by 4, so theta is equal to 3, which is our answer choice on the worksheet of C. Now, this was a backwards way of how we did it before, but it's not much more work. So, moving on to question 14, which is a very similar problem. 14 states the radius of the circle is 2. So this time it actually gives you what you need. The radius is 2. The central angle of the circle intercepts an arc of 8 centimeters. What's the radian measure? So same thing this time, except you're actually given the part you need, that the radius is 2 centimeters this time. There's an arc here that's 8 centimeters. And we're trying to find the angle in radians. So we have theta divided by 2 pi times 2 pi r is equal to your arc length. So theta divided by 2 pi times 2 pi, but this time we have a 2 here, is equal to AL. But just like in the previous problem, the 2 pi's can cancel each other out. Up in our AL was supposed to be 8. We have 2 theta is equal to 8. So divide both sides by 2, and theta would equal 4, which is answer choice C again. Well, I guess I'll leave it up for a second, but you might want to pause it, because I'm moving on to a totally new type of question, but I'm going to keep the video going. So moving on to question 16, we are almost halfway there. So we are going to go back to some old school factoring. In this particular problem, we're going to look at question 16. And question 16 says to factor the following polynomial. X cubed minus 2x squared minus 35x. So the first thing we're going to pull out is a GCF. All three have an x in common. So this would turn into x and then x squared minus 2x minus 35, because when you divide everything by x, this is what you have left. But then we're going to go by the old school way of factoring. This is b, this is c, and you need two things that multiply to give you c, and you need those same two numbers have to add up to bb. So what two numbers multiply to give you negative 35 but add up to be negative 2? So combinations to get 35 would be like 35 and 1, which can never give you 2, and 7 and 5. One must be positive, one must be negative, so the bigger one's negative. So the two numbers are negative 7 and 5. So this piece factors into x minus 7, x plus 5, and bring down the x. And you are done. That is the fully factored form of 16. So let's talk about b. And we're going to talk about this from a Desmos standpoint. You're told in b, and this one we'll just do here, and we're going to skip c because we never did factor one of those in class. The expression x plus 4 is a factor of x squared plus kx minus 20. What's the value of k? How do you know? Well, since this is not multiple choice, this will be a little bit harder because you would actually have to do it the way you're supposed to do it. So I'm going to show you way one. If x plus 4 is a factor, I guess I need my own paper for this. So for b, if x plus 4 is a factor, then x equals negative 4 is a 0. So one way we can do this, so we have the x squared plus kx minus 20. The first way we can do this is by synthetic division. We would put the negative 4 in the box. We'd have a 1, a k, and a negative 20. But we would know by the end of our problem the remainder should be 0 since it's a factor. We'll drop the 1 down. Negative 4 times 1 is negative 4. We're going to have k minus 4 here, which is weird. Then multiply these two together and we'd have negative 4 k minus 4 and drop it down. So we would set this up as negative 4 k minus 4 minus 20 is equal to 0. Distribute negative 4k plus 16 minus 20 is equal to 0. Combine like terms, we'd have negative 4k, 16 minus 20 is negative 4 is equal to 0. Add 4 to both sides, and you'd have negative 4k is equal to 4. Divide by negative 4, and you would end up with k is equal to negative 1. Now, way 2 might be a little bit easier, but you know that x must equal negative 4. So we will set up x squared plus kx minus 20 is equal to 0, but in order to solve for k, we plug in a negative 4 for every single x we see. And what's going to be funny is it will look very similar to this by the time we're through. You'll see what I mean. Negative 4 squared turns into 16 plus k. Oh, I forgot to put... Back it up. Okay, Mr. Taylor made a huge mistake. I plugged in the negative 4 for this x, but I forgot to plug in the -4 for this x. And I'm the teacher. How dare I? So this would be 16 plus -4k minus 20 is equal to 0. So if I rearrange this, I'd put the -4k in the front, put the plus 16 next, and the minus 20 at the end. And if you notice, the second line of this version is the same as the synthetic division version. We'd have -4k minus 4 is equal to 0. Add 4, add 4. We'd have -4k is equal to 4. Divide both sides by -4. And we have your k is equal to -1. And the nice thing is, this is what you have to do if there's not a bunch of answer choices. Another way, I would say, to try it, if you do not like that way, is you can still do it the way we did in class. And the way we did in class is using Desmos. So I'm going to pause this and type it in. So I don't know how this is going to go for me, guys. So I typed this in with the k. I'm going to add a slider for k. And with k, so we know, and even if you do it the Desmos way, you have to know that -4 would be your 0. So what we can start doing is guessing and checking. 1 doesn't work. So let's try 0. Nope. Let's try -1. Well, -2 I hit, but that's too far in. So I'm going to try -1. And voila, there's a 0 at -4. Guessing and checking, not a bad idea. But, anyways, let's talk about the remainder theorem. When the polynomial 4x to the 4th minus 3x squared minus 2x is divided by x minus 2, what is the remainder? So, the problem with question 17, and I'm going to rewrite the problem because I do not have room to do this. We have 4x to the 4th minus 13x squared minus 2x plus 1, and we're dividing it by x minus 2. So what we will do, though, is the issue here is you got missing terms. You got a 4, then a 2, 1, nothing. So this is really 4x to the 4th minus 0x cubed minus 13x squared minus 2x plus 1. And we're going to divide this by x minus 2. So pretty much the 0 we're going to plug in is the x equals 2, doing the opposite. So we're going to put in the synthetic a 2, and then a 4, 0, -13, -2, and a 1. 4 comes down. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 would be 16. -13 plus 16 is 3. 2 times 3 is 6. -2 plus 6 is 4. And 2 times 4 is 8. And 1 plus 8 is 9. This number here is a remainder, and on the worksheet, this is answer choice C. However, there are some questions where there might be an easier way out, and these are the ones with the weird little kx type problem. So, given the function p of x equals x cubed plus 4x squared plus kx plus 15, for what value of k is x plus 3 a factor? So, once again, the first way we could do this is synthetic division, but I don't want to necessarily do that because I want to do as least amount of work as possible. But if x plus 3 is a factor, then x equals -3 would equal a 0 of the function. So what we're actually going to do is just type all this in, and you can replace the k with your answer choices and see which one gives you a -3, where whatever this graph is crosses here at -3. So I'm going to type it in Desmos and get it set up because I'm slow. Alright, so ladies and gentlemen, this is my... Why is that light on? It's annoying. Okay. So I am going to add the slider. And I'm going to see which one gives me a -3. So the first answer choice is -26. Nope, not A. So we now type an 8. Nope. Now we type in +8. Yep, we're done. Answer is C. So we're going to skip number 19. And we'll go ahead and do 20. This one is a breath of fresh air. Go ahead and try this one. It says, what are the zeros of the polynomial function? So when in doubt, graph it out. So I'm going to type this in Desmos. I'm not going to change anything about it. I'm just going to leave it the way it is. So this is our graph. It's some ugly graph. It does some weird number like, I don't even know what it does. Going back to home. Yeah, it's like whatever, potato, and then it's like very close to the 0 and whatever. But we actually have 4 places where it crosses the x-axis at. And the x-axis crosses at -5, -4, 0. Hey, that's perfect. And then 4. So -5, -4, 0, 4. And that's our final answer. 20 questions done. So, time to do more. 21. Feel like whoever made this worksheet must have a sense of humor. So, which of the following functions has the zeros -4, 2, and 0? As I stressed earlier, when in doubt, graph it out. So the smart thing to do on this problem is just take each answer choice, graph them out, and see which one of them has, don't know what the graph is going to look like, but it's probably going to have -4 here, a 0, and then 2. So -4, 2, 0. So we're just going to type in each answer choice until we get the picture we want. So answer choice A, type in y, please be it, x cubed plus 2x squared minus 8x, -4, yay, 0, yay, 2, yay, done. Don't check the other ones. You're done. Done. X-intercept is another name for 0, so we're just going to skip 22 because it's the same type of problem. There's no point in doing the same thing over and over again. So which of the following functions represents the graph below? Now we've already done a few problems earlier so that are very similar to this, but this time we actually have the graph in front of us. So these points here are what's going to help us figure out what the zeros are of this function. So the zeros are x equals -3, 0, and 2. So if we're listing them as factors, remember if x minus h is a factor, then x equals h is the 0, and it works back and forth. So if -3 is a 0, x plus 3 is the factor. Then x minus 0, and then x minus 2. So normally if it's an x minus 0, we're going to move this to the front, it'd be x, and then we can put the other 2 in any order we want. So as long as we have these 3 in our answer choices, we're going to be fine. So the first 2 don't have everything, so A is incorrect. B, same thing. But for C, we have x, but they have an x plus 2. They're seeing if you make the mistake of forgetting to switch it. But then we have x, x plus 3, x minus 2. Answer choice is D. Alright, I'm going through this kind of quickly, but we're going to look at 24. It says which fraction is equal to this in its simplest form. So whenever you get a problem like this, and you have answer choices, what you can do to do this is we're going to use Desmos and type in this, but we're going to change it to y is equal to x squared plus 5x plus 4. So we're going to change whatever variable it is to x and we're going to plug this in Desmos, and it's probably going to be some weird looking graph. But as usual, I'm going to type it in off camera because it's going to take 5 minutes for me. Oh, a quick thing. You have to put the top in parentheses in Desmos because of all the long stuff with it. So, ladies and gentlemen, this is the ugly looking graph of this function. Now, I'm going to zoom out a little bit to get kind of a more view of it. So what we're going to do is now, instead of trying to factor this, and if you want to know how to do this, I will gladly show you the other way, the way you're supposed to do it. We're going to type each answer choice and see which one fully overlaps it in another line. So I'm going to put y equals 9 over 27, which goes through it. That's not it. I put 27. Let me double check that. 37. Not it. Now I'm going to type in y equals 4 over 18. Still a straight line. Not it. Now it has to overlap it perfectly. Y will please not be d. So we're going to type in y equals, and remember we're replacing all the y's with x's. So in parentheses I'm going to put the top, x squared, there's no x squared, plus 4 all over x plus 18. I can't even tell the difference between the two. Don't even need to check the last one. It's C. 24 down, more to go. So for question 25, we would do exactly the same thing. Figure out which one it would fully overlap, but this time I'm going to do this the old-fashioned way. So you could graph this, see which one is the same graph, but this time if we want to factor, we would have 2x squared minus 18 over 2x squared plus not 18 as well. Well, so in the top and the bottom, we can pull out a 2. If we pull out a 2, you're left with x squared minus 9. And on the bottom, you can pull out a 2, and you're left with x squared plus 9. So this is what we call a difference of squares on the top. So we actually factored that into x plus 3, x minus 3. And on the bottom, we would have 2, and then the x squared plus 9. You can't factor it. So what's left? Well, we can cancel out the 2's. So we're left with x plus 3 over x minus 3 over x squared plus 9, which is answer choice D. Now I'm going to quickly go over the other way you could have done it. I'm going to type in the original equation into Desmos. So here's the original equation in Desmos. It's an ugly looking graph, and you would go through each answer choice, and eventually we get to D. Now I want to take it off the screen. Well, now you're going to suffer through it with me. Y equals, and I'm going to have in a fraction x minus 3, x plus 3, and double close it. So now when I divide, it's all on top, and then x squared plus 9. And it perfectly overlaps. Alright. So, yeah, we're not going to do 26. 27 would be done the same way as 25, so we're going to skip it for time. 28 through 29 is just going to take too much work to do without having answer choices. So now we're going to get to the last part, which is going to move back to another formula. Now, for the previous problems, now this is weirder than anything we've done in class, but it says which measure is closest to the area of the shaded sector in the circle shown below. Now you notice these are all in degrees. So the formula for area of a sector, I guess I need actually put a little bit of work here. So we're on question 30. They can't just ask you a straightforward question. But the formula for area of a sector is, let's say you have a circle, and this time you have your central angle, and this is R, but the area of a sector, and we'll just call it AS for now, where the angle is equal to your central angle, and R is equal to your radius. The formula for it is, if you're doing it in degrees, it's theta divided by 360 times pi r squared would equal your area of a sector. Or if you're in radians, it'd be theta over 2 pi times pi r squared is equal to your area of the sector. So for number 30, this one's got like a million parts to it. And you have to be someone who was halfway decent with circles to kind of get where I start on this. So in this particular problem, it's asking what's the closest area. So we're going to do this in degrees since we have something in degrees. But we know that the R in this problem is 8. But at the moment, we just know that the angle here is 2x. So what do? We find x first. So we're going to find x because all of these angles added together would be 360. This would be 90. So if I do 2x plus 3x plus 45 plus 90, I will get 360. So we have 5x plus 135 is equal to 360. And solving this equation, it's too late in the afternoon to do this. We'll divide both sides by 5. And x is 45. So, since we've already established r is equal to 8, and since theta is equal to 2x, to find theta, we would have to do 2 times 45. So that angle is also 90 degrees. So the formula for the area of the sector, because that is technically a sector, it's theta over 360 times pi r squared, and that will be our AS. So theta now we know is 90 degrees over 360. We're going to multiply it by pi times 8 squared. And whatever we get when we type this in, we just figure out which answer choice is the closest to it. Which is 50.27, which is closest to answer choice C. So we're going to skip question 31 for sake of time and sanity. But now we'll look at question 32 because it is a complex question, but it's actually probably easier than the previous ones. So the windshield wiper blade on Yuli's car is 21 inches long. Each swipe of the wiper makes an angle of 85 degrees as pictured below. To the nearest inch, how far does the tip of the windshield wiper travel with each swipe of the blade? So that windshield wiper here, this is actually going to be your arc length, whatever you get. This would equal your radius, and this is your angle. So your angle divided by 360 times, and since it's arc length, because we're seeing how far it goes, not how much room's in between, we're going to do 2 pi r is equal to your arc length. So we'll do 85 degrees over 360 times 2 pi times 21, and that will give us our arc length. So at this point, you type it in, because since our answer is not in terms of pi, we'll just type in what we see. which is 31.2, which is closest to 31. 33, we're close to this one. So Sally's creating a flower bed that wraps around the corner of her house. She will put edging around the house flower bed 10 feet from the corner of the house in all directions as shown below. To which is the estimate of the number of feet of edging that Sally will need? Well, gee, isn't it funny that you have to know how to read English very carefully to be able to do these problems? Because it took me a while. So she would put edging around the fence. So this is more of a perimeter. So the way the picture is drawn, this is a 90-degree angle because it's a right angle. So the central angle that's drawn around here, we would do 360 minus 90, which gives us 270 degrees. So the radius is 10 feet. The angle is 270. And since we're not wanting the area on the inside, we're looking for arc length. So we will do theta divided by 360 times pi 2 pi r is your arc length. So we will do 270 over 360 times 2 pi times 10, and this will give us our AL. So 270 over 360 times 2 pi times 10 is 47.1. So the closest answer to 47 would be the 48. Fun time. So now we're skipping to actual equations of circles, ones I prefer anyways. So the formula for circles is x minus h squared plus y minus k squared is equal to r squared, where your center is h comma k and your radius is r. So what's the equation of a circle with a center at -1, -3 and a radius of 4 units? Well, this is their h, this is their k, this is their r. So we would do x minus h squared plus y minus k squared is equal to r squared. So we would have x minus a -1 plus y minus a -3 squared is equal to 4 squared. And clean it up. 2 minuses make a plus. 2 minuses make a plus. Is equal to 16. Because 4 squared is 16. So the final answer would be B. So graph is a circle on the coordinate plane. And we're going to kind of cheat on 37 and 38 because of time. I'm sure we'll be running out, and I've realized I've been talking for about an hour in a video, and I am bored of hearing my own words. Let's look at this picture here. You got to kind of figure things out. So the center of the circle is at -4, 0. So this would be our h and our k. And to find our radius, you just want to count how many units it is to get to an end point. In this case, the radius would equal 3. So using the formula, x minus h squared plus y minus k squared is equal to r squared. We would have x minus a -4 squared plus y minus 0 squared is equal to 3 squared. So we would have x plus 4 squared plus, and 0 does nothing, so we just have y squared is equal to 9, which is answer choice C. So one more time, guys. Which one represents a circle with the center? X minus h squared plus y minus k squared is equal to r squared. This is your h, this is your k, this is your r. So we would have x minus a negative 1 squared plus y minus 7 squared is equal to the square root of 17 squared. Cleaning this up to something that looks nice, we're going to have x plus 1 squared. This does not change. But here's the rule, is when you square root or square a square root, it just turns into itself without the radical. So this would be answer choice B. Now, ladies and gentlemen, I am sure most of you guys do not necessarily want to do the completing the square on 37 and 38. So we are going to do the nice little cheat of our friend Desmos, but you still have to do some thinking after you type it into Desmos. Now the beautiful thing about circles on Desmos is they show up exactly like you type them. So you don't have to do any weird stuff with it. Literally just type this piece in Desmos with everything attached, and then we'll talk. So I'm going to put it in Desmos myself, off screen. So I hope you guys can see this pretty well. I'm trying to keep both things on the screen. But we can take the answer choices and try to figure out where's the center. And I think the center looks like it's at negative 2, 5. So in a separate place, I'm going to type in negative 2, comma, 5. And that does look like the center, and it looks beautiful and perfect. So there's my center, will be at negative 2, 5. So I don't know, this is not meant to be marked through. That's meant to be underlining that. So I know it's not answer choice B, it's not answer choice D. But the issue is now you got to find your radius. And what I would say is we're going to type in the square root of 20 to see what it is, because it's not pretty, but the square root of 20 is about we're going to say that's about 4.5, give or take. But if I was to look at this picture, and I count from the center here, and this is still up by ones, 1, 2, 3 is how far it is to get to the edge. So my radius is 3 by looking at this, so your final answer is C. Which now this leads us to the last one. This one is asking us to find the radius of the circle, but before I even start this scenario, I want to find out what these two square roots are. Now the square root of 20 was in the previous problem, so that's approximately 4.5. So the square root of 2 is probably an even smaller number, 1.4. So once again, type this whole thing in Desmos, and then let's study it. Alright guys, so there's our circle. It's really hard to tell where things are, so we're going to play guess and check to figure out where's the center of this circle. So the center of the circle is going to be somewhere up here, so I'm going to start playing with numbers. I'm going to do 1, 4, and see if, that is definitely not the center. I need to move it to the right a little bit, so I'm going to change that 1 to a 2. 1, 2, 3, 4, 5, almost 6. 1, 2, 3, 4, 5, almost 6. Or maybe it is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's the same in all directions. So the radius is literally just 6 in each direction. So this one is just 6. Hope I didn't bore you to death. I know I did myself, but there is one review, and then we will begin the next one soon.